counting is a 10 to 15 minute collaborative counting activity where the class counts together in unison as the teacher scribes the counting sequence. As teachers record the count, the students are encouraged to ask questions and notice emerging patterns.
All right, let's count these numbers together. Ready? On the count of 3. 1, 2, 3.
2 8s, 4 8s, 6 8s, 8 8s.
When we look at these, do we see any fractions that remind us of equivalent fractions that we might already know? What are you thinking?
8 eighths would be a whole.
That's right, 8 eighths would be a whole. How do you know that?
Because the numerator and the denominator are matching.
They're matching, that's right. And that means that we have all the parts out of
Eighths.
Out of 8. All right, that's very good.
Counting sequences are intentionally planned to support the instruction of the mathematics standards in the classroom and capitalize on children's innate interest in numbers. Choral counting is more than just a routine. It's an opportunity for students and teachers to explore, wonder, and build safe learning communities through mathematics.
All right, so now let's choral count these numbers again. Ready? On the count of 3. Ready? Go. 1, 2, 3.
2 8s, 4 8s, 6 8s, 8 8s.
All right, let's continue our pattern. What do you think if we stopped with 8 eighths? What do you think our next number is going to be?
10 eighths.
2 is what kind of number? A whole. Are we adding by whole numbers? No. What are we adding by?
8.
We're adding by 8. So we're adding actually by 2 eighths each time. All right, so now what do you think the next number is going to be?
It's going to be 12 eighths.
All right, next number.
14 eighths.
All right, so what would be our next number in our sequence after 14 eighths? What are we going to get?
16 eighths.
In primary grades, choral counting lays the groundwork for children to begin thinking about whole numbers, to identify patterns and predict what happens next in the counting sequence, and to justify their thinking as a result of counting together. When students make connections, experiment with patterns, and apply new learning to their fractional understanding, their confidence grows. Today's choral count was very carefully designed. The goal is for students to not only observe patterns of addition, subtraction, and multiplication in fractions, but also for students to make connections to fraction equivalents that they can later apply during the day's math lesson.
Do you see any other fractions up here that are equivalent to something you already know, or other fractions?
16 eighths is equal to 2 wholes.
All right, anything else that we see?
10 eighths is equal to 1 and 2 eighths.
All right, very good. All right, so now let's choral count. All right, let's start at the beginning. All right, ready? 1, 2, 3.
2 8s, 4 8s, 6 8s, 8 8s, 10 8s, 12 8s, 14 8s, 16 8s.
All right, very good. So what you have done is you have found equivalent fractions using mixed numbers, using benchmark fractions that you already know.
Daily number routines don't always have a direct connection to that day's instruction. They could be used to keep previous learning top of mind, or to continue to work on a tricky skill once the class has moved to other topics. They might be used to encourage mathematical dialogue between students, or to practice flexible problem solving, or to sharpen mental math skills.
All right, guys, let's take a look at our learning target for today. One more time. It says, I am learning to record data on a line plot using hand links measured to the nearest 1/8, 1/4, and 1/2 using a number line. Yeah, I'm going to visit with her because I was impressed that she picked out the multiplication of times 2. And nobody else saw that connection. So I'm going to visit with her. I think this is a great idea to start with him because he sees the relationship between the multiplication. I think he just needs clarification on exactly how to set that up and what it should really look like. Okay. What do you think, now you have a beginning and an ending spot, what are you going to do with all of that other data?
All that other data will probably go in the middle.
Okay, and how are you going to show that data?
Put a dot in between.
You're going to use dots. Okay, y'all go ahead and take care of that and plot your line plot data, and I'll be back, okay?
Yes, ma'am.
All right, very good. Okay, I see you have some X's. What do these represent on your line plot?
So this one was one measure. This one was two. So they put 2 X's.
Oh, so you're using that X to represent everybody's measurement. Okay.
How did y'all get 7 1/4?
We got 5 1/2 as our smallest and 7 1/4 as our biggest. And then we subtracted the 2, but first we had to find a common denominator.
Why did y'all just subtract and multiply all of that
To get 3
to get 1 3/4?
5 minus 7 it equals 2. And the 2 that is left with the 7.
Oh, I see. I see where y'all get 2/4 from subtracting 5 and 7 to get 2, and you bring the 2 down here to 2 1/4. Then the fractions are just like right there.
I would like to say that I really like the way that you two respectfully disagreed and that you were able to conversate and work through your differences to help each other learn. All right, so you're looking at your math practice and your proficiency scale, and you're thinking up what evidence you have from today that can prove, all right, that you've met your goal. The first box says, I can interpret data in graphs, pictures, bar, and line plots to solve problems using numbers and operations. If you think you can do that after your vertical classroom today, go ahead and check that off. If you already had it checked, you should have some evidence after today that proves you can do that. The next box says you can create a line plot to display a data set of measurements and fractions of a unit. Those units are 1/4, 1/2, and 1/8.
And remember, this means correctly without any help. You can do it independently.
Take a look at what math practice you have circled on your desk and what you have marked on here. Take a look and think of what evidence do you have from your learning today, okay, that proves you have met your focus for today, and maybe you have something new that you can check off. On the bottom where it says your mid-learning self-score, remember, you probably already have a number there. It's okay if this number doesn't change, okay? You may not have all the evidence you need yet to prove that you can do all of those things, and that's okay. So maybe your number stays the same, or maybe it goes up depending on what learning you got today from your classroom and from our turn and talk during our walk around.
I can kind of do some of those fractions from our board, but not all of them.
So what does that mean for you on your proficiency scale?
I need some improvement on that.
So where would your mid-learning be then? Not at a 2?
Probably a 1.5.
A 1.5? Okay, I like that.
I can do the first 2 correctly, but I'm still having trouble with the last one. So I'm making that as a goal. And my mid-learning self-score would probably be about a 1.8.
Go ahead and look at your math practices that you circled this morning that you set as your focus for today. If you think that you were successful in paying attention to that focus and you have some evidence that goes ahead and supports that, go ahead and give me a thumbs up right here.
Today, the teacher and coach have purposefully planned to use the daily number sense routine as a launching point for the day's math lesson. The students have the opportunity to practice a necessary foundational skill directly before applying it in context. This makes the math more accessible for all students.